So here's the third video from lesson 6.1, and here we're going to be multiplying monomials. But before we can multiply monomials, let's define what a monomial is. So first, the definition of a monomial. A monomial can be a constant, just a variable, or a product of a constant and one or more variables. So for example, just the number 5. Yes, that's a constant, but it can also be considered a monomial. Just a variable x can be considered a monomial. But a typical monomial would look something like this. Maybe not so many variables, but a product of a number and variables. And then the coefficient is an important part of a monomial, and the coefficient is the numerical factor of a monomial. So I have highlighted in red the numerical factors of each one. So this would be the coefficient, the 3. Here the -5 would be considered the coefficient. And here that fraction 2/3 would be considered the coefficient of that monomial. All right? So now we'll look to see what can we do if we're asked to multiply monomials. So first of all, to simplify the product of monomials containing exponents. If we want to simplify the product of these two monomials. So the first thing we're going to do is we're going to remove the parentheses, and we're going to rearrange and group them with their same basis. So we're going to group the coefficients together. So the 5 and the 7 are grouped together. And then we're going to take the c's. So we have c squared and c. We're going to group those together. And then we have the d to the third and the d to the fifth. And we're going to group those together. And now we're going to simplify by using the product of powers property where necessary. So 5 times 7 is 35. We're going to add the exponents. Remember, when there's not an exponent, that's understood to be a 1. And our final answer then would be 35 c to the third d to the eighth. So we'll look through a couple of examples here on your next slide in your notes. So first example here, I would group the coefficients. So I have 4 times 7. And I'm going to group the powers that have the same base. And now 4 times 7 is 28. And then y to the second times y to the fifth would be y to the seventh. So again, pretty simple concept. Remember, in this problem, this has a coefficient of 1 here. So this is a -11 times 1. Then I have an x times an x squared I'm grouping together. There is no other y, so that's just y to the third. And then I have a z to the third times z. And now I simplify. -11 times 1 is a -11. Remember, that's to the first power, so that's x to the third, y to the third, and then z to the third times z would be z to the fourth power. And then our last example here. Again, we don't have a coefficient here necessarily, but it is a -1 there. So I'm going to have -1 times 7. Then I have w to the -5th times w to the second. Then I'm going to have x to the -3rd times x to the 4th. And then I don't have any other y's, so that's just y to the -2nd. So now I'm going to simplify. Well, this would be -7. W to the -5th times w to the second would be w to the -3rd. X to the -3rd times x to the 4th would be x to the 1st. And then I'd have the y to the -2nd. Now, if you recall, at the beginning of this lesson, we're not allowed to leave any 0 or negative exponents. So a negative coefficient never moves. That just stays. That's a -7. And the x is a positive exponent, so that's going to stay. But now I have to move my w to the -3rd and y to the -2nd. They're both above the fraction bar, so I move them below the fraction bar to change the sign of the exponent. Move the y to the -2nd below the fraction bar to change it to a positive exponent. And now there's my final answer. So again, we're starting to combine a couple different ideas along the way here to help us with simplifying monomials.